Hello everybody, welcome to this session. I am Rafia Sabih and here is my colleague Fabrízio. So together we are going to introduce you to continuous aggregates. It's a unique feature of TimescaleDB and also it's like a next step to what is native to Postgres materialized views. So at the beginning of this we will see what is TimescaleDB and then we will pitch forward why do we need continuous aggregates, and for that we will first start with a brief refresher of what are materialized views, when they are helpful and when they do not. Then it will give us a good time to introduce like why we need things like continuous aggregates and why they are performing better, and finally we'll close the talk by seeing what is the next and where it is also going forward, in what direction. So about TimescaleDB, it's an open source relational database which specializes for time series data. So it is packaged as an Postgres extension. So it gives us a benefit of using all the existing Postgres infrastructure. But the thing that is unique with it is like it provides and optimizes the different parts of the engine in a way which is suitable for time-centric data. So in a nutshell, I can say that it is likely to help you if you are running a lot of complex queries on data which has high ingest rate, and also you are not very happy with the time series related analysis tool and functions that are already with Postgres, and you need something more, then TimescaleDB is likely to help you. So, but what are the things which are typical to this? We will introduce like a very few of them, but the basic part of it, because we will use it in this part of the presentation also. So the first thing is hypertables. So hypertables are nothing but like partitioned tables, but on time. So now whenever you create a normal partition table, that is a hypertable, it will be divided into multiple partitions, which we call as chunks. So each chunk has a given time range, and you will find the data of that time range in that particular chunk. So that helps different features and also this modeling on time series data in many ways. And the other thing that is peculiar to TimescaleDB is its hyperfunctions. So we call it hyperfunctions because they work on hypertables. And one of the most common and most used one is time bucket, which provides you the ability to bucket your kind of group or aggregate your data into different time slow it like different intervals. It could be minutes, milliseconds, weeks, days, months, years, anything. So that becomes very handy. So we'll start with the first part, which is the introduction, or in that sense a refresher to materialized views. And here is a small setup that we have done, which we'll use for running examples in the whole of this presentation. So basically we are using a very common scenario of time series data, which is like the stock market. So we have a table called company, we have a table which is stocks real time, which is having the price and different other aspects like symbol and the volume for different stocks. And then now is the magic part of timescale is create hypertable. So as soon as you call this function, your table is now partitioned and you specify your time column. To see and compare it with the views, we are creating a view also, which is called stocks company. It's basically a join from stocks on stocks real time and the company to get the different important aspects that we want to see, like price and volume, etc. So here is Postgres materialized views. So we are creating a materialized view, which is we calling as stocks company mat. So it looks similar to the view we have done previously, but the good thing about materialized view is that it runs and stores the query result in a view. So it's kind of like caching of query, and we know the benefits of caching, so it helps us in that way. The other good point with the materialized view is that it has the provision to have indexes on it. So it makes the processing faster. Now let's have a test query to compare materialized views and like how it processes. So the query we are dealing here is just mapping the different prices at different time for a given company, and for like a time period of 4 days here we have taken. So when we look at the plan that is coming from materialized views, it's kind of simple, and yeah, it is like working in 50 milliseconds. Good, fine. Let's see what view has to offer. So when we do it with a view, it's a little bit more complex plan involving a join, and it's not so good. Well, that's a good thing because that's what we were looking for. So it's like 78 milliseconds. So on comparing both of them, yes, materialized views helped. But if we would have looked a little bit closer, if I would have given you more time to look at it, you would have noticed that the actual work that was being done was almost similar in both the cases. Why so? Well, because again, we have not yet optimized our query for what is the use case of materialized view for, let's say. So we can see that for both the scenarios, the view and the materialized view, the amount of data that is to be processed is same. So yes, in some certain scenario it could help, but the actual work that is to be done is same. So we were not using materialized views in the best ways maybe, and we could have used it where it was required. Like in this finance data, this phrase called open, high, low, close queries, which is like a low granularity query. And it is like you want to analyze a particular stock for a time frame and things like that. It is suited for those type of scenarios because we can clearly see that now it's like aggregated, so a lot lesser rows and a lot less amount of data to be processed, so it is likely to be fast. Well, that is not all that we are for. So it might be fast, but how about we are in stock markets, so time goes by and too much ingest, too much inserts are going on. Our materialized view cannot cope up with that. So it is getting outdated every now and then. Can we help? First of all, let's see how and why it was this, because as we understand from the architecture of materialized view, it is nothing much but just a normal table which is populated at the time of creation of the query. That is, like when we first created the view, we run that query, we store the results. So it is likely to get outdated very fast. But in this regard, views which were like very basic were helpful because they never were out of date. But it still is not everything because views are slower, as we have seen. But materialized view is also not just done yet, because now we have refresh materialized view in Postgres, which is like you can get your materialized view updated at any moment. But looking at it closely, what it does, whenever you run a refresh materialized view, it just truncates your whole materialized view and now runs the query again on the new data, which is their base table, and then give you an updated materialized view. Sounds good, but we can very well imagine that as the data volume goes up, it is not likely to be very performant, and it will be like a lot of blocking because we are taking off like too much data, we are truncating every time, and then we are running the whole query on that whole amount of data, which is not preferred. So now we have perfect time to introduce continuous aggregates. What it does, as its name suggests, is like it continuously and incrementally updates our materialized view. So whenever a new amount of data is added, it only integrates that new data, it aggregates that new data, and then adds it to a continuous aggregate. That sounds very helpful, but how do we do that? So the way we have devised for it is what we've termed as watermark. So we keep a track of till where our data was materialized last, and then we can just go from that point of time in our base table and see what else is added. And we can just run the query on that amount of data and we are done. And like the important part is that every time we need to refresh, we are aggregating things, we have to update our watermark. So for the next part, we will see how the refresh works now for this new type of materialized view. For this part, my colleague Fabrízio will take over.
Hi, everyone. Hi, everyone. So, my name is Fabrízio. I work for Timescale as a software developer. The refresh of continuous aggregate, how this works. As Rafia said, we don't need to refresh the whole data of a continuous aggregate like we do with Postgres materialized views, because we keep track of the watermark. The watermark is the point in time where the data is materialized. It means that giving this information, I can read just the new data inserted into the original hypertable, the raw hypertable, and do aggregation just of this part, this window range, and do the materialization. Do insert or delete on the continuous aggregate, depending on the case. How this works, we run a query with the last materialization. We no need to drop all data. It's just run with newly data added to the original hypertable. And we can set up a policy. A policy in Timescale is a concept, it's a job, a background worker. We have a scheduler implemented in Timescale that we schedule policies to run in background to do some jobs, to refresh continuous aggregate, to execute retention policies, to compress data, and also to run custom jobs developed by ourselves. The continuous aggregate itself takes advantage of normal views and materialized views, because it's much faster, the refresh procedure, than a normal materialized view, and it's always update. But what happens if some data is inserted in between? I mean, for example, here I'm inserting data, the new data, append-only mode, but because this is a time series, I'm just ingesting new data, moving to the future. But what happens if you insert data in the past or change the data in the past, do a update or a delete? We handle this. This is an example. I change a data in the past, and I should also update the continuous aggregate, this range, this window frame, in the past of the continuous aggregate. In order to do this, we have a concept of named invalidation log. It means that if I insert a data in the past, I change a data in the past, do an insert, update, or delete, we create an invalidation log, a record in a table, that when we refresh again the continuous aggregate, we will process this invalidation log and keep this range, run the aggregation just for this specific range, and update this inside the continuous aggregate. So this is much, much faster than do a refresh materialized view in vanilla Postgres, because you should aggregate all the data again. Oh, this is another information, but I will move to another slide about real-time views. Here, what happens, for example, when we insert data in the last bucket of time, the green points at the left, the right, we are inserting data in the last bucket, but the continuous aggregate refresh the data just until the last full bucket. It means that the last bucket of the original table is not updated, but we have another kind of type of continuous aggregate named real-time view that combine data from the materialized hypertable, because behind the scenes, our materialized hypertable, it's our materialization table is a hypertable, because hypertable is a foundation of timescale. Then we combine the data that we read from the materialized hypertable and do a union query with the whole hypertable. It means that we read the data from the past of the watermark, reading data from the materialized table. It means the materialized data, and after the watermark, the real-time part of the data from the original hypertable. And this, under the hood, is something like this. We select data from the materialized hypertable and get the watermark, check the bucket less than the current watermark, union with a query over the original hypertable. So we keep track of the watermark, and we can read the data in past of the watermark and after the watermark. After the watermark, we read the data from the original hypertable, and in the past, the already aggregated and materialized data. This gives to us a notion of real-time aggregation. It means that new data that are inserted into the original hypertable will be available in our continuous aggregate, because this architecture that we implemented in TimescaleDB. Yeah, this is what I explained. And here we have another concept that we developed. We released it 2.9, I guess, if I remember correctly. The hierarchical continuous aggregate. Have a look on this hypertable and this continuous aggregates. We are aggregating data by minute, by hour, by day, by week, by month, and by quarter, and by year. Several different continuous aggregates. But each of those continuous aggregates need to read data from the original hypertable. It means that I should do aggregation by minute, by hour, by day, based on a lot of rows from the original hypertable. But with this new concept of hierarchical continuous aggregate, I can create a continuous aggregate on top of another continuous aggregate. It means that, for example, if I have millions of records in original hypertable, I can aggregate by minutes, and we reduce a lot of the amount of the records, because we have the data aggregated. And then I can create another continuous aggregate on top of this one instead of the original regular hypertable, and then we have less data to refresh. So it keeps the refresh procedure very, very fast. So we can create this this kind of architecture, a lot of continuous aggregate on top of another. We can create this continuous aggregate real-time or materialized only. Another advantage is we can have different retention policies for each level. It means that I can have a retention policy in the whole hypertable. For example, let's say I will keep just the last month of data in the original hypertable, but up there we have by year. I can have aggregated data 5 years ago without having the original data, because you can set up different retention policies for each of the continuous aggregate. And this is another advantage of this. And also the refresh procedures will be much, much more faster, because we will read pre-calculated data to do an aggregation. Of course, there are some issues around this, especially when how to solve, for example, the average of average problem, because in this first continuous aggregate, I can have an average calculation, and then by hour another average. And if you do a calculation average of averages, will not be the same result as a true average that should sum all of the lines and divide by the total the count of the lines that we are do a sum. For this specific problem, we have another extension named TimescaleDB Toolkit that we have some special hyperfunctions to do two-step aggregation, roll up, and so on. So we can store the partial state of the aggregation in the materialized the hyper table behind scenes, and then do a query over this aggregated data and finalize the aggregation, and we will have the real result for this issue. Well, what's next? Here's some limitations that we have. Continuous aggregates are not for free. For example, we should use a time bucket function. We can't nowadays create a continuous aggregate without time bucket. It's mandatory to create a continuous aggregate with time bucket functions. The joins nowadays is limited to 2 tables. It means one hyper table and another regular table and inner join, right? An inner join. Also, we can't create continuous aggregate over regular tables, only regular tables. We should have a hyper table, we should have a time bucket function. There are some aggregations that don't work yet. Window functions are not possible yet. But I guess besides this, the majority of queries will work very well. For the future, nowadays, the most important thing about the refresh. If you have a big hypertable with a lot of data, and you create a continuous aggregate, it means that you should populate, you should materialize the data, right? Like we do with regular materialized view, you should do a refresh in order to populate the data in the materialized view. Nowadays, the refresh procedure is not parallel, and it can take longer to do the first refresh of your continuous aggregate. But there are some workarounds that you can do there. We can do several refreshes manually in parallel in using different time ranges. But we should add a properly parallel refresh process behind scenes, because this is somehow weird nowadays. Another thing to implement for the future is join with multiple regular tables and extend some cases that don't require time. We are doing several investigations to extend the continuous aggregates and the hypertable itself to don't be tied just on time-based partitioning. And there are some crazy ideas that we are thinking about. Instead of have this architecture using a watermark and a union query over the materialized data and the original data for the real-time aggregation, we are thinking about do logical decode-based refreshing. It means that behind the scenes, the background work, we will decode the wall, the records that are changed in the original hypertable, and using wall decoding, logical decoding, we can incrementally ingest and update, refresh the data into the materialized. So it means that we will not need this both queries, the union query, and just have the materialization table with a kind of real-time aggregation behind the scenes without policies, just configure it. And also a continuous aggregate without hypertable, just for regular tables. This is something that we are thinking about. Yeah, and that is. There's some questions actually that we want to do for you guys. How do you think we should extend continuous aggregate, and what you look like to see in our extension? And also now feel free to ask some questions as well. The invalidation log, depending on how much data you update in the past, right? Because if you update a lot of data, let's say if you do an update changing all the rows of the original hypertable, it will take time because it will refresh the whole continuous aggregate. It will depend on the amount of data you changed in the past. But if you have a append-only application, it will be very fast because we will just refresh the new incoming data.
So I guess that if you're backfilling, so you're adding data or modifying data in the past, you cannot use functions that may be not prepared for some because they're dependent on previous results. Like for example, imagine you want to compute the SHA hash of the previous row, all the previous rows with the current one. In this case, you'll need to
Yeah.
so that one will not be supported.
Yeah, this is because we don't support window functions, and
Right.
this is the reason.
It's hard.
Yeah, it's not easy.
Is there any plan? Is there any plan to implement window functions?
It is on our roadmap, but we didn't start to think about how to solve this. Maybe we can start with some limited cases of window functions, but yeah, we have this problem. It's not easy to solve, but this is on our roadmap to improve the continuous aggregate. Anyone else? Another question? We move fast.
I have one more question. Is there any plan to like we have multiple time frames that we are talking about exactly the same data, right? So we have like 1 minute, 5 minutes, or like 1 hour, 1 day, 1 week. And when people have like really massive amount of data, what is very common is like you need to mix a bit of everything. So for example, when you do the union how in the raw data for a daily bucket, for example, maybe you get like 7 hours. So is there any plan to do some like query plan optimization, which could get data from different sources and mix them? Because for example, in a daily, I could mix like 6 hours and then plus some minutes and just like go to a very minimal amount of raw data.
I don't understand very well your point.
Yeah, I mean like when for example, if you are getting like a daily continuous
Okay.
aggregate, right? Using real time.
Okay.
So you are looking for the last 3 days. So the last 2 days are already materialized.
Mm-hmm.
But actual day, you need to go to raw data. So let's say you are storing like 1 billion metrics per day. Going to this daily raw data is very expensive. So you could just fall back to hourly data that's already aggregated into last hour, and then just mix a very little amount of this type of thing, like just go more advanced use cases. Like we need, because actually we built this type of queries by hand, and then I was just thinking like maybe some of this could be internalized.
Yeah, probably yes.
I would suggest this.
Talk to my manager. No more questions? Please.
So, can you go back to the thing about the average of averages? So, I wasn't clear on how this works. Does that mean that if you, let's say the only aggregate you use is average, and then you create hierarchies on it, does it mean that it will anticipate that hierarchies will be created on it and also store the count in the sum?
No, no. It will start the partial state of the aggregation using this function. Let me show you one example. We have some time. Here is one example. Can you see my screen? Here is the first, the base continuous aggregate, the first one that we connect direct to the how hypertable, right? Then we store this stats egg that is a partial state of the aggregation. And then we do, for example, in the next level, we do a roll up to have also the partial state of the partial state. And then when you query the data in your application, you just do something like this. Sum, the status, this sum is a specialized sum function. This is not a Postgres function because this stats is a special data type. It's a vector. And this average is our average implementation. So we have those hyperfunctions to store the partial state of the aggregation, do the roll up when you have multiple levels, and we need to finalize the aggregation using some special functions to do this. Actually, what we did here, we decompose how the aggregation functions work in Postgres. Because when you create a custom aggregate function in Postgres, you create a state, a transition state function. You should create a finalize function to finalize the aggregation, and the state actually pick the current row, apply some calculation, return the row, and the row return, apply some calculation, and do a transition row by row to compute the aggregation. And at the end of the aggregation, you should finalize. What we are doing here is just decomposing those functions at the user level for the SQL level, and you can use for free. Sorry?
At some level, you have to anticipate whether you want or need that stats.
Ah, yes, you should.
If you only want some, then you might not want to pay.
Yeah, yeah. But it will depend of what aggregation you are using, right? Because there are some aggregations that you don't have this problem of averages. A sum, a count, something like that. Please.
The average user aggregate has been defined at the timescale wasn't anticipated. It's just your private aggregate. You have your own finalized function. Does this work fine with that?
Yes, it will.
It doesn't have to be something like average that we've anticipated. It could be any old.
Yes, exactly.
I'll just couple more. One is so the timescale toolkit is timescale license and continuous aggregates are also part of the Apache or timescale.
The timescale license. Yes. The Apache license is hypertables. I guess essentially hypertables and compression, I guess. I don't remember. No, compression. No, compression is part of the timescale license. Time bucket is Apache license. Yeah, the basic stuff of the TimescaleDB is Apache license. There's all those more advanced features are TimescaleDB license.
And with continuous aggregates, can they be compressed?
Yes. All these features, hypertables, continuous aggregate, we can apply policies to retention. We can apply policies to compress data, to apply compression. It means that the continuous aggregate, the data stored into the materialization hypertable will be compressed. And also we can do retention, refresh, compression. Yes, those are the major features of our extension. Please.
If you have a smaller table of the complete data, and then say you have the last year's worth of weekly data and the last decade's worth of yearly data or something like that, and then some guy comes in and inserts a row for 7 years ago into the main column, and you update the stats.
Exactly. Yeah, because it will. Yeah, actually, in fact, doing this, you will lose data because you don't have the previous data, and it will create an invalidation log for this specific point in time, and then when we process the refresh, this range, this bucket will be removed, and just your new data will be aggregated. So you should take care of it. Doing gap fill data, if you do a retention and you don't have any data and then start a lot of time ago. Yeah, you should be careful about this. Any other question? Okay, thank you so much.